I want to show you another example of a equilibrium constant calculation problem. So here's our equation: 2p plus 5Cl2 gives 2pCl5, and here's the information we're given. We're given the starting concentrations of Cl2 and phosphorus and an equilibrium concentration of Cl2 as well. Alright, so we get started and we'll do the equation first. And we'll start off with an initial concentration here, so it'll be initial in molar. And the phosphorus concentration initially is 8.000 and Cl2 is 1.500, and the initial concentration of the product will be 0 because this is all we're going to be starting off with. Now at equilibrium, we know it's going to be 8.00 minus 2z, and this will be 1.500 minus z, and this will be 2z. So what's going to happen is that the concentrations of the reactants will go down, the concentration of the products will go up, and they'll go up and down in accordance with the stoichiometry of the reaction. So it'll go down by 2z, down by 5z, up by 2z. So this will end up going down by as much as this one goes up, and we expect that based on what we see here. Alright, so we've got this information. The other piece of information we have is that at equilibrium, the concentration of Cl2 is 0.5000 molar. Alright, so we know then that this business here, 1.50 minus 5z, must also equal 0.5000. So then when we figure out z, it'll be minus 5z equals, and it would be negative 1.000. Now the number of significant figures here will be based on the decimal places. There's 3 decimal places here and 4 decimal places here. So that gives us that, and z will equal 0.2000. Now 4 significant figures, because we have 4 sig figs here, and 5 doesn't count for significant figures because it's a counting number. So z is going to come out to 0.200, 4 significant figures to match what we've got here. Alright, so we've got our z under control. Now what we can do is go ahead and calculate out our k value. Now k is going to equal pCl5 to the power of 2 over p to the power of 2 and Cl2 to the 5th. Now we can go ahead and substitute in all our values. We'll have 2z all squared. Whoops. And then we'll have 8.000 minus 2z squared, and then we'll have the Cl2 to the 5th. Now what I'm going to do here, instead of putting in the 1.500 minus 5z, I'm going to put in the amount we were given at the beginning, which was 0.5000. This will avoid any later problems with significant figures. If I'm given this, then that's the maximum number of significant figures I'm allowed for that anyway. Alright, so now I need to do a little bit of a significant figure check. I've already square on this. We know that that's 4 significant figures. I have to figure out the number of significant figures I'm going to get from this though. So we've got 8.00 minus 2z, and that's going to equal 8.00 minus and this will be 0.4000, because that's going to be 2 times that amount right there. So that comes out to 7.600. So we know that that's 4 significant figures as well. So that's 4 sig figs. And up here we've got 2z squared. That's definitely going to be 4 sig figs as well, because there's no addition subtraction going on there. So any answer we come up with is also going to have 4 significant figures, and our answer is going to come out to be 0.08. Let me take that away here. 0.08864. And there's our final answer right there.